we are going to talk about acid-base reactions. And single displacement reactions. And combination and decomposition reactions. And finally, combustion reactions. So you will have to be able to identify all of these types of reactions. I'll go through each type, and then at the end, I'll do a summary of all of the types of reactions that you will have to know for this test, and just kind of quick ways you can remember those. Does everybody have this down? Excellent. Okay. Acid-base reactions. I also call these neutralization reactions because you might know that if you treat an acid with a base, that it causes it to neutralize. So, for example, if you ever spill acid on yourself, you should pour a base on it to neutralize it, and vice versa. Can anyone tell me what an acid is? How you identify it? Hydrogen. In our class, there are many. There are kind of layers of identifications of acids and bases. We're going with the most basic definition. It's called the Arrhenius definition. But in our definition of an acid, it always has H plus. And so it contributes H plus to the solution when it dissolves. And this causes pH to decrease. So pH is the measure of H plus in solution. And it's kind of an opposite scale. So the higher the level of H plus, the lower pH. So the more acidic something is, the lower the pH. So high H plus, low pH. And so something like this would be HCl. When you put it into a solution, it turns into H plus and Cl minus, and therefore you have increased the H plus concentration by dissolving HCl in it. Can anyone tell me what a base looks like? OH, hydroxide. So a base contributes OH minus to a solution when it dissolves. And pH increases. So for example, NaOH breaks up into Na plus and OH minus. Now you might be wondering, well, if pH is the measure of H plus, why does putting OH into solution change the pH? It's because when you have H plus in the solution and you add OH minus to the solution, what do those two make together? Water. So that is, sorry. H2O, and this is what we call neutralization. H plus OH minus go to neutral water. So the more OH minus you have in solution, the less H plus you have because they're going to go together and make water. Any questions on this so far? So an acid-base reaction should always have water as one of its products in this class. When you get to 111, you'll learn about wider definitions of acids and bases. But in this class, an acid-base reaction should always have a product that is water. So for example, if we have a molecular equation that looks like NaOH plus HCl goes to H2O and NaCl. So what I did was I took the OH and the H plus, they went together to create H2O, and the Na and Cl went together to create an ionic compound. So you have a base plus an acid goes to water and ionic. If I have just NaOH and no H plus, is that an acid-base reaction? If I only have a base but no acid, is that an acid-base reaction? No. If I have an acid but no base? No. So you can only have an acid-base reaction if you have both an acid and a base, okay? If you have both an OH minus and an H plus. So you're complete ionic for this. Oh, let's do our phases. What's the phase of NaOH in aqueous solution? Take out your solubility charts. You should have your solubility chart out. You should have your periodic table out. Sorry, what? So it's not solid. It is aqueous. Then why is it aqueous? I don't know, I guess. Hannah, why is it not solid? And Na is a 1A element. It's an alkali metal. So it's soluble, which means it's aqueous. You got to know those exceptions. All right. HCl. Solid or aqueous? Aqueous. It's a 1A. H plus in our class is always going to be aqueous. What about water? Liquid, right? Because that's a solvent. So water is just a liquid. There's one case you'll have to know where it's a gas, but and then what about NaCl? Aqueous. Eleanor, why is it aqueous?
Because chlorine is always soluble.
It's mostly soluble, and Na is not an exception. Exactly. All right. So now, what are we going to do for our complete ionics? What can we not break up? The liquid, the water. You cannot break up a liquid. So we're going to have Na plus OH minus. I just broke up the NaOH. And then I'm going to break up the HCl into H plus and Cl minus. Then I'm going to go to H2O, leave it there, and Na plus Cl minus. What are our spectator ions? Cl minus and Na plus. So our net ionic is going to look like OH minus plus H plus, goes to H2O. And look, that's the neutralization reaction I just wrote earlier.
spectator ion, even if it's not anything soft, precipitate?
I will do an example where it does make a precipitate.
Anything that's not aqueous is like what it's producing.
Yeah, so anything, you cannot break up anything that is not aqueous. So you can only break up the NaOH, HCl, and NaCl. Why is this not double displacement? They sort of do though. Like OH minus goes with H plus, and Na goes with Cl. But what are all of the compounds in a double displacement have to be?
It doesn't go from A, B, C, D to A, D.
So they do like H plus and OH minus do go together, but is H2O ionic or molecular? It's molecular. Because ionic is only going to be solid or aqueous at room temperature. So because H2O is a molecular compound, one of the requirements for double displacement is that they all have to be ionics. Okay? So this is not a double displacement reaction. It is just an acid base. All right? Let's do another one. Yeah. Aqueous at room temperature, which we're always assuming these are happening at room temperature. Is this balanced?
No.
What do I need to do to balance it? What's the first thing you see? Yeah.
HCl.
You need 2 HCl's because you need 2 chlorides. And now yeah, 2 waters. Because you have 2 H's here plus 2 more H's, that's 4 H's on the left, and you have 2 O's on the left. So you need 2 H2O's so you can have 4 H's and 1 O on the right. Now, what are my phases? HCl, we already know that that's aqueous. How about calcium hydroxide? Aqueous because calcium is an exception to the solubility of hydroxide. And we have liquid. And how about calcium chloride? Aqueous. Lysander, why is it aqueous? Calcium is not an exception to the solubility of chloride. So that's an aqueous as well. So we did our balancing. So now we're going to go to our complete ionic. We have 2H plus 2Cl minus plus Ca2 plus 2OH minus, because that 2 is not part of that polyatomic ion. There's 2 OHs. And then we have 2 H2O and Ca2 plus, and then once again, that 2 is not part of that chloride ion, so you're going to bring it out front to Cl minus. What are our spectators? Cl and Ca2 plus. Excellent. So your net ionic is actually going to look really similar to the one above. It's just there's 2 of them, which I would accept. Once again, I would accept this form or the reduced form where you just divide everything by 2. This is not always the case for your net ionics. It's not always going to be H plus OH minus goes to H2O. I will show you for your net ionic. It's very common, but there are cases where you can have a different net ionic.
If you write like 2H plus and plus 2OH minus, do you want us to put 2H2O?
Yes, it has to be balanced, but you could just take the 2's away, just divide everything by 2, okay? So you would either leave it like this, or you divide everything by the common denominator. Excellent. Okay, let's do an example where your net ionic is going to be slightly different. Let's do, your molecular equation is going to be let's go through and let's do our phases first. H3PO4, what's the phase? Aqueous, why? H plus is a 1A, and it's an exception to the insolubility of PO4 3 minus, so it's going to be aqueous. We just found out that calcium hydroxide is aqueous. H2O, as we know, is going to be liquid. How about calcium phosphate? Solid. Why is it solid? Calcium is not an exception to the insolubility of PO4 3 minus. PO4 3 minus tends to be insoluble. Calcium is not an exception to that, so that's going to be a solid. So this is an acid base. It's also another type of reaction that we've talked about. Can anyone tell me what that is? Precipitation. Excellent. We have a precipitate here. We started with all aqueous and we ended up with a solid. So if I asked you to identify this reaction, you would identify it as both acid base and precipitation. Okay, let's do our complete ionic. How many H pluses do we have? Oh, sorry, we need to balance it first. It's not balanced. How many H3PO4s should we have to balance this? We would need 2 H3PO4s because we need 2 PO4s to match the other side. And how many calcium hydroxides do we need? 3, because on the right we need 3 calciums on the left. Now, can anyone add up those H's and O's and tell me how many H2Os we need? 6. We have 2 times 3 H's, 6, plus 3 times 2 H's. That makes a total of 12 on this side, which means we need 12 H's on the right. And then if you count up 3 times 2 oxygens, you find that you have 6, and now we have 6 on the other side. Now, how many H pluses do we have in our complete ionic? 6. Because we take that 3 out, multiply it by the 2. How many PO4 3 minuses do we have? 2. How many calciums do we have? What? Thank you. 3. 3 Ca2 plus. How many OHs? 6 OH minus. And what do we do with the right side? Can we break anything up on the right side? No, we just leave it. 6H2O plus Ca3PO4 2. So you notice that since we have all liquid or solid on the right side, we can't break anything up. Now tell me, what are my spectator ions? I heard the right answer. None. So your net ionic is the same. Okay? You have a net ionic because you haven't crossed anything out. Okay? It's just the same. Don't write none. Don't leave it blank. It is the same. So you can write same, arrow, or you can rewrite the whole thing. I would accept those 3 answers. Any questions on that? Yes, Hannah. When everything crosses out. Yeah. So when, like, for example, if you have a double displacement with no precipitation and everything crosses out, that's when you have no net ionic. But most of the time you have some sort of net ionic. It's just not this. It's just sometimes the same as the complete ionic. Yeah.
Break up the product because they're not aqueous.
Yeah, you can only break up aqueous because remember, aqueous means that you have ions floating around in solution. Liquid and solid doesn't mean that. Yeah. All right. Where are we? I would like to talk about single displacement reactions. This is another one of those reactions that I can represent as just a series of letters because it doesn't matter what you're adding together, it matters how they are combined. So A plus BC goes to AC plus B. In a single displacement reaction, one thing starts out as an element and then it kicks another thing out of the compound. So in this case, A is an element on that side, B is an element on this side, and they switched places in that compound. Does everyone see that? I'll give you some examples. So in your molecular, you have solid zinc plus CuCl2 goes to ZnCl2 plus Cu solid. So I will give you the phases. I will give you the phases of elements because I don't expect you to know those, but assume this is in aqueous conditions. So I need you to tell me what the phases for CuCl2 and ZnCl2 are. Can anyone tell me what those are? They're aqueous, yeah. So what am I going to break up for my complete ionic? The two compounds. This is very important. I'm going to repeat this several times today because I see this mistake so much. Do not give a charge to a neutral element, okay? Zinc is neutral. When you bring it down into the complete ionic, do not give it a charge, all right? Zinc just comes down. Just think of it, if it's a solid, you don't change it, you just bring it down, okay? So I didn't change anything except I just didn't include the solid phase label. But I didn't change anything with zinc, do not give it a charge. And then CuCl2, since it is an aqueous compound, you can break that up into ions because that's an ionic compound. So you have Cu2 plus 2Cl minus goes to Zn2 plus 2Cl minus plus Cu, which does not have a charge. This is another thing I will repeat myself on. You cannot cross out a neutral element on one side with that element's ion on the other side. So what is the only thing you can cross out? Cl minus. It has to look the same on both sides. Zn is not the same as Zn2 plus. Do not cross those out. Same with Cu and Cu2 plus. So your net ionic is going to be Zn plus Cu2 plus goes to Zn2 plus Cu. You'll notice two things about this. It is balanced in terms of your atoms, which we always want for our net ionics. It is also balanced in terms of charge. Both sides are not neutral, but the same charge is on both sides. We have 2+ on both sides. You always want your net ionic to be the same charge on both sides, whether that's neutral or positive or negative, okay? Any questions on that? I'm going to give you a practice one. I'm going to let you guys finish writing this out. Okay. Ag plus HCl. I want a phase for HCl. I also want a phase for AgCl and H2, which is a gas. Balance it. Give me phases that are missing. Then give me the complete ionic and net ionic. All right. Raise your hand if you have questions. I'll be right back.
You don't break the salt. I mean, altogether at one of the two, like, there's 2 of them, so +1 +1 +2. Like -1 -1 makes -2. Yeah, so it's always has to be neutral. Yeah.
Okay.
Does that make sense?
Remember, if something is solid, liquid, or gas, you shouldn't change it when you bring it down into the complete ionic. Big difference. This is what I-
I just do it because there's not a simple like that makes sense. Yeah, and my grades are exactly like
But you have a pretty unique one.
yeah. But still, yeah. deviation shall.
All right. What's my phase on HCl? Aqueous. Acids are aqueous in this class. Okay, so aqueous. And what is my charge on AgCl? I mean, not my charge, my phase on AgCl. Solid. And how many silvers do I need? How many hydrochloric acids do I need? How many AgCls do I need? How many H2s do I need? One. So we are now balanced. And what can we break apart here? Only HCl. Okay. So 2Ag plus 2H plus 2Cl minus goes to 2AgCl plus H2. Do not break apart that H2 into 2H. It is still hydrogen gas. It does not change. So if anything is a phase besides aqueous, you cannot change it in terms of what it looks like from the molecular to the complete ionic. What's my net ionic here? Same. You cannot cross any of these things out because 2H plus is very different than H2. Okay, so same or arrow, or you could rewrite it. Questions on this? Excellent. Let's talk about combination and decomposition reactions. In my opinion, these are the easiest to identify. So a combination reaction is exactly what it sounds like. A plus B combines to form AB. It can be, you can have more than 2 reactants. You can have 3 things coming together to make something. The point is that it's more than one thing combining to make one compound. So if you have more than one thing on the left and you only have one thing on the right, that is a combination reaction. So these are things like 2H2 plus O2 creates 2H2O. Or 3O2 plus 4Fe goes to 2Fe2O3. More than one thing combining to make one thing. Decomposition reactions are exactly the opposite. They decompose into multiple things. So you start with one reactant and get more than one product. These are things like, you can actually have the exact opposite reaction of the combination. For example, if I wanted to look at the decomposition of Fe2O3, it would just be the opposite of what I wrote above. Yeah, Elliot. All compounds can decompose. Not all will. Like sometimes you have to add heat. Sometimes you have to cool them down. But pretty much every compound decomposes at some temperature. Yeah. But you don't have to go, you don't have to decompose into elements. So here you decompose into elements, and you don't have to have elements combined. You can have something decompose into multiple compounds, or you can have more than one compound come together to make a one compound. So what I'm talking about here, for example, H2SO4 can decompose into H2O and SO3. Still a decomposition reaction, because you start with one thing and you go to two things. It just doesn't decompose directly into elements. Any questions on that? Once again, these are, in my opinion, the easiest to identify, because it's just how many on the left, how many on the right. All right. Let's talk about combustion. What are the three things you need to start a fire? Oxygen, heat, fuel. Yeah, something that you actually burn. So, because in elementary school, I learned the triangle of fire. You know, the three elements you need to, or the three things you need to make a fire: heat, fuel, and oxygen. So that's what a combustion reaction is. You need the fuel, which is, we're just going to say it's something, plus oxygen, O2, and you will add heat, but we don't have to draw that out, goes to H2O, gas, and CO2, gas. So in this case, you will have to identify, I won't necessarily tell you the phase of oxygen or CO2 ever, because those are things that you breathe in and out, so you should know that those are gases at room temperature. Generally, if I ask you for the phase of water, it will be liquid, except in the case of combustion reaction. Can anyone tell me why water is gaseous in a combustion reaction? Why don't you see water trickling out from a fire? Because heat. Combustions reactions are exothermic. Remember that? They release heat, and they release enough heat to make all water produced water vapor. So when you have a fire going, yes, you're releasing CO2, but you're also releasing water vapor, okay? So generally what you will see in my class is CXHY. It's a hydrocarbon burning. So CXHY plus O2 goes to H2O gas plus CO2 gas. So X and Y can be any numbers. We had to balance those last week, and also I think on Wednesday. So if you see C something, H something plus O2 goes to H2O and CO2, that is a combustion reaction. Okay? Any questions on that? You will have to know the phases of those compounds. I'll give you the phase of CXHY. Don't worry about that. All right. There's a special reaction that you need to know. And it involves bicarbonate. Does anybody remember what the bicarbonate ion is? HCO3 minus. Okay, so NaHCO3 aqueous plus HCl aqueous creates H2CO3. So the H from HCl went with the HCO3 from the sodium bicarbonate, and they made H2CO3. and then you have NaCl. So what type of reaction does this look like? Something we learned last time. It looks like double displacement, and it is double displacement, but something else happens. H2CO3 is not stable. It decomposes into H2O liquid plus CO2 gas. So this is both a double displacement and a decomposition reaction. So I might give you this part, and you will have to give me the products, and you will have to show this. I will accept this in two ways. What you can do is you can write H2CO3 and then an arrow showing the decomposition reaction, and just like cross that out. Or you can just write H2O and CO2 as products. So this is a decomp and a double displacement. Does everybody see how we got H2O and CO2 from H2CO3? So we have the two hydrogens and the three oxygens, 1, 2, 3, and then we have one carbon, which is CO2. This is just something you will have to remember, okay? If you get a product that comes from an acid and an HCO3, it creates H2CO3, and then that breaks down into H2O and CO2. Any questions on that? All right. I'm going to do a summary of all of those reactions that you need to know, and then we'll do some practice problems that will be like the ones on the test. What I mean by specific reactions is that specific reactions depend on the actual reactants and products given and their phases. General reactions are the ones that are just about placement with like A and B and C and D, those kind of things. So specific reactions that you need to know are precipitation. What's the definition of a precipitation reaction? Solid in the products, no solid in the reactants. So it's either aqueous, liquid, or gas goes to solid, right? So non-solids go to at least one solid. Acid base. What's acid base, you guys? Yeah, but what's an acid? What does it give to solution? What does it give to solution? Hydrogen plus. And what does OH, sorry, yes, an acid gives OH to solution. So you're going to have an acid and a base, and one of the products is going to be H2O. And then we just talked about combustion, which is something plus what? O2 goes to H2O in gas form and CO2. And so those are the three types of specific reactions that you will have to identify. And then general types of reactions are double displacement. So AB plus CD goes to AB plus CB, and they are all ionic. Single displacement, A plus B, C goes to AC plus B. Combination is A plus B, goes to AB. And decomp is the opposite of combination. These will never overlap, except in which case? Double displacement and decomposition when there's a bicarbonate and an acid. So generally, these will not overlap except in that last case, that special reaction. But these can overlap. You can have acid bases that are precipitation, and you can have some from both. You can have reaction types from both general and specific. You can have a double displacement that's precipitation. You can have a single displacement that's precipitation. You can have combination and decomposition that are precipitation. Any questions? You need to be able to identify all of these. So yeah, what's up?
Can you repeat what you said about how they'll never overlap?
These four are never going to overlap except in that special reaction case that's both double displacement and decomposition. The HCO3.
Yeah.
That's the only case that these will overlap. These can, and these can, but these four are general reactions. Let's see which one I want to give you guys. Okay, I want you to predict the products, balance, give me phases, do the complete and net ionics, and then indicate all that apply. This is the kind of question you will have on the test. Okay. Obviously, there will be less questions because a lot of them will have all of these parts. It's going to be about the same length as your other tests. And we'll be doing more of these on Monday as well, and Tuesday. It's also this, right? Yes.
Yeah.
I mean, it can. Yeah, there are different things. Yeah, and you won't have to predict that. Yeah, you only have to predict like acid-base, double displacement, and yeah, and things like that. You have to be able to predict. Yes. Yeah, there are many different ways things can.
But you might have to balance.
Exactly. Watch your balancing.
See it for the goal too? What is this? What is going to happen here? Give it acid.
You have to be able to recognize that. You have an acid combining with bicarbonate. It's just different balancing. Save your balancing until after you've written out all your products. Otherwise, it will be very confusing.
I would start off with
Sorry?
It's gonna have something hard for what we have.
If you add an acid but then and then I recommend study
Calcium bicarbonate is soluble.
I would give it to you. Yeah.
Oh, question also like that.
Now what does that mean?
Yeah. Yeah.
Yes. And then balance it. Calcium bicarbonate is aqueous. I would give that to you. Because that's not something you have in your solution. Bicarbonate. Oh, are you talking about? That one you have to figure out. What is it? I'm actually gonna write it out. You can keep working, but it is the end of class time, so I'm just gonna write this the answers out. That's wrong. Sorry. Is that right? No, I need. I need a 6 there, right? 6 and 6. Yes, that's correct. And then this is going to be aqueous. It's going to be aqueous. This is going to be a liquid. This is going to be a gas. And this is going to be solid. So it's going to be 6H plus 2 minus 6HCO3. HCO3 is a polyatomic ion. You do not break it apart. Is this right, Chris?
Yeah, I think it looks good.
Yeah, the 6 is right, yeah.
Yeah.
Okay. And then, let's see. This is a double displacement and a decomposition, and what else? Not an acid base because you don't have a base. It's not combustion because you don't burn something with oxygen. What else? Precipitation. Excellent. So you you have to make sure that all of the things required for a specific type reaction are there if you're going to call it that type of reaction. All right? So yes, you have H2O and CO2 as products, but it's still not a combustion because you didn't have oxygen on the other side. Excellent. I will see you on Monday and Wednesday for review and Friday for the exam.